So in this video, we're going to talk about what smooth and continuous means. Now, all polynomials are smooth and continuous. And what continuous means, unofficially or conceptually, it means there are no breaks or holes in the graph. So I should be able to draw the entire graph without picking up my pencil if it's continuous. Now, what smooth means that there is no corners, cusps, or sharp edges. So what you can envision for smooth when we say a graph is smooth, imagine that would be a track of a roller coaster. Would you want to ride it? Now, you don't want to ride anything if it has a sharp corner or a point, because that would make for a very uncomfortable roller coaster ride. So that's what I kind of envision when I think of smooth. So for example, if I had a graph that looked like this, I don't think I would want to ride that if it was the track of a roller coaster, because when it got to this point right here at this cusp, it would be very jerky and it might come off the track. So you want something that would look like this. This would be considered smooth. That would be a roller coaster ride that I would want to go on. So that's how I like to explain smooth in a conceptual way. Is imagine that you're taking a roller coaster ride. Would you want to ride on that? Is there any sharp corners or cusps or any jagged edges? So when you look at a graph, you'll be able to tell if it's a possible polynomial, if it's continuous, and if it's smooth. So if you look at this first graph here, I'll call this graph 1. This is definitely continuous, because I can draw that whole graph without picking up my pencil, right? There's no breaks or holes in the graph. So that's continuous. However, I wouldn't call that smooth because it's got a point. So I would say this is not a polynomial, because polynomials have to be smooth and continuous. This example, number 2, this is definitely continuous because I can draw the whole thing from beginning to end without picking up my pencil. There's no holes or breaks in the graph, so this is continuous. And this is also smooth because there's no sharp corners or edges or weird cusps. So I would say that this is a possible polynomial. Now, for example 3, there are no sharp edges here. However, it's not continuous. Because I can't draw the whole thing without picking up my pencil from here to here. I would have to pick up my pencil. There's breaks in the graph. So I would not consider this a polynomial. All it has to do is fail one of these 2 conditions. So it has to be continuous and it has to be smooth in order for it to be considered a polynomial.